I'm going to go a little faster through the second problem because I took some time in the first problem to kind of set up why this all works. And so at this point now we can kind of just trust it does, and we can just kind of move forward. So I want to find the distance of this red line. Again, I could use the Pythagorean theorem if I wanted to, but I want to exercise the distance formula. And so the first thing I'm going to do is give myself the inputs for the distance formula, which in this particular case are actually going to be coordinate points. So what I want to do on these coordinate points is just write them next to these two endpoints. And so let's see, we have 1, 2, 3, 4, 5. And so this is going to be 5 comma negative 1 for this guy. And for this other endpoint, we're going to look at, let's see, 1 comma 1, 2, 3, 4, 5, 6. That's like a weird label, but that's going to be 1, negative 6. So now in terms of like understanding what these points are and where they come from, remember one of these are just two endpoints for the formula. And so I can kind of look at this one and say, well, this is x1 and this is y1. In other words, the x and y values of like that point. Then I can look at the second guy and say, well, this is going to be like x2 comma y2, which is like the x and y values of that second point. Now the reason that's really important is because I'm going to use distance formula to solve this instead of Pythagorean theorem, and the distance formula actually needs those inputs. So the distance formula says the distance is equal to the square root of, and then in parentheses, x2 minus x1 squared up, plus y2 minus y1, that should also be squared, because remember, this comes from the Pythagorean theorem. So now it's just an issue of like inputting the right pieces. And so just like before, I'll do some quick highlights here. So we have x2, which would be that guy. That's just what I designated it. And then we're going to subtract off x1, which is going to be this 5. Let's see, then we need a y2. Well, the y2 is a y value of the second point, which is a negative 6. And then last but not least, we have y1, which is going to be the y value of our first point. Now we do want to be careful here because I'm seeing some negatives, and that could mess me up on the back end of this. But that's why these first couple steps are so important to establish that you actually know the idea behind the distance formula, and what you're messing up on is just maybe some of the transfers. Okay. But either way, let's go ahead and set this up. So we have two numbers that will be subtracted, and then I'll square them. Another set of two numbers that will be subtracted, and I'll square those as well. So let's start picking out the pieces. So I need x2. x2 is just going to be a value of 1. And then if you notice, my formula already has a subtraction sign right here. And then I'll take the x1 value, which is going to be 5. Okay, now we'll move on to the y's. We need y2, which will be negative 6. The formula itself has a subtraction sign. And then it asks me to take y1. Well, y1 is actually negative 1, so we're actually going to set up a double here, a negative and then another negative 1 behind it. I'm going to change this color to gray just so it's a little easier to read. So negative, negative 1, then we have negative 1 here as well, okay? So if you get this far, again, you kind of won the battle. All you have to do is carry through the arithmetic correctly. And so let's do some simplifying in small steps. So let's just first get 1 minus 5. Well, if you take 1, subtract 5, you end up with negative 4, which will square. Then we have negative 6, subtract the negative 1. Well, keep in mind that actually is going to be a plus sign. Two negatives make a positive, so we have negative 6, and then we're going to add 1 to it again. Well, negative 6 plus 1 is going to give me a negative 5. Okay, we'll square that value as well. Continuing, so we still haven't resolved the square root, but we now do have negative 4 squared. And this is the beauty of the squaring. It's always going to be a positive number as a result. So negative 4 squared is going to give you 16. Negative 5 squared is going to give you 25. Okay, so adding together, let's see, we have 20, 30, and that should give me 41. Kind of overshot my square roots. And so again, like this would be a perfectly fine answer to leave it, just square root of 41, because there is no exact answer to that, meaning I'm going to have to do some rounding and square rooting. But again, we can also go here and take 41, oops, you can't see that, 41, and then take the square root, and it was 6.403. And again, that 1 is not going to round to 3, so 6.403 seems to be our answer. So also approximate 6.403. Okay, again, let's check the reasonableness of our work. This distance being 6, well, that's going to be bigger than both the 4 and the 5 that we had for our side lengths of that triangle. So 6.403 is pretty darn reasonable. So again, kind of in review of this problem, distance formula is weird at first, but it just has you input some values to tell you the sides of that triangle that you could have drawn. And of course, you could always go back to the Pythagorean theorem and double check this, or use that technique outright. But if you're using the distance formula, you want to make sure, and this is the most critical part, that the x2, x1, y2, and y1 are coming from the right places. Because if you can't substitute them in correctly, the distance formula just isn't going to work. And so this is a little bit more finesse mathematics, in the sense that like if you don't have to do all this extra drawing and Pythagorean theorem stuff. If you have the right formula stuff to input, right? From there, we have to carry through some arithmetic. Subtract first, of course, because order operations, then square, and then add together before you square root. But in the end, we end up with 6.403, and that's going to be the answer to the second problem. All right, thank you.